So to find g of 6, we have the function for g of x, and just replacing the value of 6 for x, so we're going to have 5 plus the integral from 6 to 6 of f of t dt. So that's going to be 5 plus the integral from 6 to 6 is just 0, so g of 6 is 5. Then to get g prime of x, we're going to take the derivative with respect to x of that g of x function. The derivative of 5 is going to be 0, and the derivative of the integral, going to cancel out, the x will go into the function, so by the fundamental theorem of calculus, g prime of x is f of x, and g prime of 6 is going to be f of 6, and off the graph f of 6 is at the number 3, so g prime of 6 is equal to 3. To get g double prime, just take the derivative of g prime, so derivative of f, which would be f prime of x, so g double prime of 6 is going to be f prime at 6. Problem says that f has a horizontal tangent line that's x equals 6, so that means that f prime of 6 is going to be 0. So g double prime of 6 is 0. To find out when g is decreasing, that means when g prime is going to be negative, and g prime is the same as f, so we're trying to think about when is f going to be negative. So off the graph, when is the f graph in the negative section, and that's from negative 3 to 0 and from 12 to 15. So g is decreasing on the interval from negative 3 to 0 and 12 to 15. Because g prime is negative on that interval, and the negative 3 and the 15 are both included because they're both still in the negatives. When is g going to be concave down? That's when g double prime is going to be negative. G prime would be decreasing, which means that we're thinking about when is f decreasing, and f is decreasing on the interval from 6 to 15, so g is concave down on the interval from 6 to 15 because g prime is decreasing on that interval from 6 to 15. Finding a trapezoidal approximation, we have delta t is equal to 3. We're looking at equal subintervals, so the integral from negative 3 to 15 of f of t dt is going to be the trapezoidal sum, so we have 1/2 delta t, which is 3. Then the first y value, which is negative 1, twice the next y value, which is 0, twice the next y value, which is 1, twice the next y value, which is at 3, twice the next y value, which is at 1, twice the next y value, which is at 0, and the last y value is not doubled, and that's a value of negative 1. Then just simplifying to get the answer of 12.